Marijuana. Hello? Negative. Yep. The combination of kids who have been gone the last couple of days, plus a couple during third hour that are going to be gone for track today. We're going to do that quiz on the unit circle tomorrow. Also, we're right smack in the middle of section 4.4. I just want to keep rolling with that and get the graphs figured out. Instead of interrupting that, I want to make sure we get that done today. And then we'll do the quiz tomorrow. So, what we have gotten done in the last couple days is we talked about these trig functions, the basics of them. We messed around with amplitude, reflections, and we started the changes to the period. So, this one's got all three. It's all about where does it start and do the dance. Suppose we should do that whole attendance thing.
Those still from those of Blake. Or cars. Those can get expensive.
Or rip the radio out of the center console.
Okay, I kind of forgot that people are crazy.
Yeah, that happened to me in college. I was even late for my class. Parked my truck, went in. I was in for maybe 20 minutes. Came back out. Whole center of my dash was torn to pieces, metal parts all over the floor. It was a 92 Silverado, and there was a trick with that type of door frame where you could just punch a screwdriver into the passenger door. Done. Leave a hole that big. You'd never even know that it happened if you didn't look at the passenger door. And I'm pretty sure I saw them driving off too. Anyone still rolling? Okay. Should be relatively quick. The things we know. Number one. I know the amplitude is 1/6. We haven't gotten to vertical shifts yet, so I'll have a midline of 0, and I'll go up to 1/6 and down to negative 1/6. That part's easy. I have the period is 2 pi over b. B is 1/7, so 14 pi. So I'm going to go from 0 out to 14 pi for one period. I'm going to go from 0 back to negative 14 pi for another period. So 0, 14 pi, negative 14 pi. There we go. And though it is never mentioned in any textbook, the relevant features of a sine and cosine graph are going to happen at 1/4 of the period. So I'm going to take that times 1/4 and get 7 pi over 2 increments for my x-axis, or my horizontal axis. So we'll go from 0 to 7 pi over 2 to 7 pi, well, I suppose it's just 7 pi, and then 21 pi over 2 or 14 pi, and their negative counterparts. And then it's just a good old sine graph. Sine of 0 is 0. And because this has a negative in front of it, I will not then go up to the maximum, I will go down to a minimum. And continue the dance of down, middle, up, middle. Up, middle, down, middle. Connect the dots, try to keep it curvy. And you got yourself the function. So, the pieces of it are, did you get your vertical axis, meaning you labeled your amplitude? Did you get the period correct? Whatever the period was, even if you got it incorrect, did you then break up the rest of that axis correctly by quarters? Did you start at 0 because it's sine? Did you head downward because it was a reflection? Okay. So, period, quarter marks. Vertical axis, starting at 0, went down. Yes, ma'am? Distance from the midline, because today we're going to shift that up and down.
So it's never going to be negative.
Correct. That's why specifically the amplitude will say absolute value of A, because just like with all of our other function transformations, A will include both vertical dilations and vertical reflections. Okay? So you mark the thing. Uh-huh. Because from here to here is one period. Because from there to there it will hit all of its values. It'll go down to the minimum values, it'll go up to the maximum values, and then at that point, it'll start to repeat itself. So, the homework wasn't much, it was just practice 4 of these. Okay? Oh, I just opened the window from Remind. So. Boop. So, we left off with changing the period. I know that we did that. I'm reasonably sure I did one of these and then set you loose on the other ones. Yes? Oh, okay, we did these two, but we were going to do that one. All right. So, whoop. What if I switch that to 11/4? Because so far, all of the changes to the period we've had are either an integer in front of x or x over an integer. What happens when I combine the two? What if I have just a straight up nasty fraction? No, it's just the period is 2 pi over b. The period is 2 pi over b. Dividing by fractions is easy as pie. Flip the second, multiply. The period is going to be 8 pi over 11. And then my quarter marks are going to be that times 1/4, or 2 pi over 11. Graphifa! Y'all, is just fractions. I know that sometime around 6th grade when we started letting you use a calculator, you just forgot how fractions worked. But you big kids, I know you can do it. We got to be able to work with fractions because today we're going to do the phase shift in addition to changing the period. And it's not a big deal if they have compatible denominators. But when they don't, and you need to get common denominators in order to make things work, that's when things get weird. And not even weird, just not pretty. It does say to put two on the same set of axes. How many of us are just graphing the red one right now? Okay. Do you see how having quarter marks of 2 pi over 11 and quarter marks of pi over 2, that's going to be like trying to run an Android emulator on a MacBook. It's going to cause problems, right? Oh yeah, you can run BlueStacks on anything. But if you don't know all the tips and tricks, it's going to get nasty. So what I'm going to have you do from this point forward, if it ever says to put both on the same set of axes, just do two separate ones. Okay? So don't worry about doing this one. I just want you to see this and panic, because that's going to cause problems, isn't it? So don't worry about it, just graph that guy. Okay, we have from 0 out to 8 pi over 11. Quarter marks are 2 pi over 11, so 2 pi over 11, 4 pi over 11, 6 pi over 11. Negative counterparts. I don't see a change to amplitude, so I will put 0, 1, and -1 along my vertical axis. And what we were saying yesterday is that if you don't like having all of that writing in the middle of your graph, I got no problem with you putting this off to the side and putting all of this down here. Because I know for some of us, that's just really bothersome to have all of that writing in the middle. Plus, some of you just write gigantic. So having that in the middle of our graph might be problematic. If you write everything off to the side like this and it's labeled, well, then it's just regular old cosine. Cosine starts at midline or maximum? Maximum. And does it have a reflection to actually say minimum? No, just check it. So I start up here and I do the dance. Middle down, middle up. Middle down, middle up. Connect the dots. And cosine will look like your big W. Okay? So the big thing with these isn't so much the graph itself. I think we got that yesterday, just the different points. If I just do that up, middle, down, middle, dance, it's the same thing every time. It's matching and labeling the axes so that it works for you. Remember back when we were doing quadratics? Ancient magic. You're like, oh God, I missed that. What if I had said something like, I want you to graph -17/31 x squared. Big brain says how about I go over 1, down 1, over 2, down 4, over 3, down 9. Make my regular parabola and then say times 17/31 for my y-axis. Yes. I said this when we reviewed quadratics, like day 3. Okay, that's how we are going to approach sine and cosine and tangent and cosecant and secant graphs. We are going to make the same graph every time. We're just going to relabel the axes in the appropriate manner. Okay? Here. 1, 2, 3. Okay. I want you to start keeping track of every time she says the word sleigh.
Why'd you have to bring out 35? No, it's 60. Why are there 60?
Yeah.
Stop. Stop it.
So, absolutely.
She gets her own board then.
I didn't think 60 on that. That is last.
So,
I'll take one. I will find one.
ready? We've already talked about the period of a function. 2 pi over b. Does anyone remember yesterday we also talked about frequency? What was the difference between them? B over 2 pi, it's a reciprocal, where period is how long, or not how long, how far, I should say. How far to complete one cycle. Okay? A normal sine or cosine is going to go to 2 pi. So if I take that divided by b, it will stretch or compress it appropriately to how far will it take to complete the cycle. If I flip that, it's how many cycles in this far. And I say that because you can always reduce it. So like if I do b over 2 pi and just leave it, it's how many cycles will I complete in a 2 pi distance. You see where you could reduce that down, like say it was 6 over 2 pi. I would reduce that down to say there's 3 cycles per pi distance. Okay? So we talked about those a little bit, and then they gave you examples of where my music geek's at. Musical notes classified by frequency. Tempered scale, middle C, has a frequency of 262 hertz. Use that information to write an equation. The thing at the left was just a picture of like a keyboard with different frequencies on it. Doesn't matter. Write a sine function that can model the behavior of the sound wave associated with having an amplitude of 0.2. They just told me amplitude. If I have y equals a times sine of bx plus c plus d, remember that was our form, what information did they give us? Well, they told me the amplitude, so I know that much. So I got y is 0.2 sine of, what other information was I given? I was given frequency. So specifically, if they told me that the frequency was 262 hertz, I can just off to the side, 262 is b over 2 pi, cross multiply solve, and get b is 524 pi. Y'all, I'm exhausted. Like, check my mental math. Okay. So, cross multiply, I'll get b is 524 pi. That means I now know b. 524 pi x. That's all the information I was given. They didn't say anything about a phase shift. They didn't say anything about a midline. So that's it. That's my function. I was able to write my function because I know what frequency is now. Ta-da! That's it. Like, that's the whole problem. Okay? Yes! I just need to know.
I didn't say it. I didn't say it.
If you would, second one, please. Go! Yeah, but I'm tired and I don't think of stuff. Y'all, I'm sorry to say, but all semester long, you're experiencing Sullivan at like 61% capacity. Okay, I'm normally not this impulsive or dumb, I swear. I'm just tired. Yes, Goblin number 2 has lost all ability to regulate himself for sleeping after having 5 ear infections within 7 months last year, culminating in surgery and tubes. Now if he wakes up, which he usually does 1 to 3 times per night, he comes to find Daddy. It's Goblin 2's birthday today. Yeah. Yep.
Make it go 5. Make it go 5. Yes. No. We're up to 5.
Cool?
Yes.
Same thing, they give you frequency and amplitude. Amplitude just gets jammed in front of it. Frequency I use to find B, jam B in there, I'm good to go. Cool? All right.
Oh, yeah.
That's also why, like, I'll make a bigger point of putting curves on S's if it's actually involved in a formula or something like that. And that's why I tell all of you that if you're working on a problem and it has different variables, if those variables don't stand for something specific in terms of a formula, change it. Because S's look like 5s, Z's look like 2s, T's look like pluses. Like, it sucks. Is that Z2, 2Z, or 22, or ZZ? Which is also why I always put a line through Z's. Yes. So, all right. This is the part where we have to do fractions, okay? Phase shift. Remember, we're not calling it a horizontal translation anymore. Horizontal translation, that's what's happening. But sine and cosine functions are special. So we give it a special name. We call it phase shift. I don't want to repeat this part. Notice that in the past, we've always had y is a by f of we always separated b from the x minus h. But in the standard form of sine and cosine functions, they don't do that. So if I wanted to know what c is, I would have to factor out and then if I wanted to solve for that, okay? So if I wanted to know what that phase shift was, what that horizontal translation was, because they didn't separate it for me, because they didn't say x minus h, taking care of that bass-ackwards land, they didn't do any of that for me in the standard form of this, I have to know that the phase shift is negative c over b. Okay? Now you could have done this all the way back through transformations in Algebra 1 and 2. You could have just said that the horizontal translation is always h over b and just never factored. Okay, so those are all interrelated. Notice that again, they're going to say absolute value of b. It's not necessary for us right now because we are not going to have a negative b value. If you put a negative in front of x, in front of your input value, what that's going to start doing is changing to positive and negative angles as you change integers. So think of it, normally my angles rotate like this, right? Positive. But then negative angles rotate like this. So if I had a negative b, what it would effectively do is make this, 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 and then they would start to overlap. Like that. If you had a negative b, that's what would happen. You would have alternating portions of the circle. And it would get funky. I don't even know if you do that in trig. Okay, that might be college trig. So don't worry about it. We ain't going to see a negative b. Okay? Phase shift is a horizontal translation, which means I'm going to take sine and I'm going to shove it over that far. Now, it's really difficult to start, say, in between pi over 2 and pi, but I need to start like 2/5 of the way there because my period is going to be pi over 10 increments. That's nasty. So what I'm going to do is when I have a phase shift, I said make the axes work for you. I'm just still going to start my sine right there, but I'm going to label it wherever I started. Okay? I'm going to make it start wherever I feel like, because that's going to be easier than trying to fit it to someone else's scale. Have you ever anyone ever taken a trip abroad and tried to fit a normal American plug-in into someone else's outlet? You don't just keep hitting it until it works. That's a quick way to electrocute yourself. Yeah, because aren't they like that? Something like that, right? Like, they're different. Okay, additionally, we're going to do it after messing with phase shift. Midline. Midline is a vertical shift. Instead of being at 0, I'm going to shift up or down depending on whatever D is at the end. Notice that 1 is not grouped in the parentheses. That's how I know it's the vertical shift. What most textbooks want you to do is just like this, make your midline, and then work from there. I would rather just label my axes 1, 2, 0, like that. Okay? If I get to label my axes the way I want, this isn't nearly as difficult as they want to make it. Yes. I think I do, but let's wait until we get to the vertical shift before I see it. If my filter translated that appropriately, yes. But I need to see it first. Okay. All right. Here we go. Step 1. I see a 1 in front of it, so I will state that the amplitude is 1. I even heard that one. Lori, keep up. Because I fully expect her to get to 60 by the end of the class. If there's nothing back here, then I will say my vertical shift, there is none. Okay? Period. Period is always 2 pi over b. What is b? 3. Okay. So, good thing I'm a dad. Do what I say, not what I do. 2 pi over 3 is my period. I've been waiting like 30 some years to say that, so. Now, the period may be 2 pi over 3, but all of these boxes are going to be broken up as 1/4 of that period. So take 2 pi over 3 times 1/4. My quarter marks are going to be in pi over 6 increments. Phase shift. The phase shift is negative c over b. What is c? Negative pi over 2, because the form of this is bx plus c. So the negative pi over 2 goes here, the 3 goes here. Negative negative is positive. Pi over 2 divided by 3 is the same as pi over 2 times 1/3. Negative times negative is positive. Because it's a negative pi over 2. Here. Better? Okay. So a negative negative is positive. Pi over 2 over 3 is the same as pi over 2 times 1/3. So the phase shift, very ironically, is pi over 6. When that happens, I could still start with 0 in the middle of the graph. But I'd have to understand that I would start my sign over at pi over 6. I'm going to show both. I would put pi over 6 in the middle. Okay? I have Smartboard. I can shift entire thing and show you what I'm talking about. So I'm going to start with my phase shift. Pi over 6 in the middle. And then I have to go out 2 pi over 3 from that, 2 pi over 3 from that. No, I cannot just put 2 pi over 3 at both ends because pi over 6 plus 2 pi over 3. Now do you see why I said you got no fractions? Pi over 6 plus 2 pi over 3 is 4 pi over 6 becomes 5 pi over 6. I said blue.
So the one, like, the closer one will be 2 pi over 3. That one is the next.
Do we get that phase shift goes in middle? Do we get the quarter marks are pi over 6? I'm going to count in pi over 6s. We just have to reduce them. Because 1 pi over 6, 2 pi over 6, reduce. 3 pi over 6, 4 pi over 6, 5 pi over 6. Okay? I don't. The period is still 2 pi over 3. It's just I'm moving that far from here. Is the entire period. The green is the quarter marks. Uh-huh.
Because originally we started 0, so 4 points on here, since we started here, main one, and then
You two understand each other, so good. Yes? I got to go the other way. What is 1 pi over 6 minus 1 pi over 6? Minus 1 pi over 6. Negative 2 pi over 6. Negative 3 pi over 6. Okay? This is where kids get confused with it. It's not the graph itself. It's fractions. Would it help if above these I said 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 0, negative 1, 6, negative 2, 6, negative 3. Okay? It's just fractions. I have to start at 1/6 of a pi, and then I'm going to move in pi over 6 increments. It's just I have to reduce them, and I got to put pi's next to them. Yes. Getting there. Because my phase shift is pi over 6, that means I'm not starting here. Don't make this line. I'm starting over here. Does sine normally start at 0 or 1? 0. So on here, it's going to look like the same graph. Up, middle, down, middle. Down, middle, up, middle. It's going to look like the normal sine graphs that we were doing yesterday, but it's shifted over pi over 6. So what I'm showing you, yeah? Okay.
And then that line where it was talking about like the middle, just put it like put it up to the 2-1 now. Alright, you get what I'm saying? No, like all of that, like all the values between,
Like make the one have 2 marks. Don't you say?
like just like that one. So it'd be like the second one, that one be 1.
And then
How we were doing it yesterday,
Oh,
that we were
yeah.
spaced out.
She's saying just make your voice.
Oh! Yeah, go for it. Why didn't you just say, can I change the scale so that it goes by halves?
I'm saying, like, can I just do that at the same time for like the.
Yes.
So, are we supposed to draw that white line?
No.
I didn't know what line was.
Okay. The reason that I put the white line there is to show you, because the phase shift matched my quarter marks, I could have just started at 0 like normal, but I would have to remember to start my graph over here at pi over 6. Because from there I go down. I would just start the dance at pi over 6 instead of at 0. You can only do that when the quarter marks and the phase shift line up. Okay? Which is why I said you might not want to do that and just keep pi over 6 in the middle, because that's how most of them are going to be. Because what happens when that line, what happens when 0 is like 3/8 of the way between the boxes? Then you're screwed. Okay? So that's why I said just put the phase shift in the middle. And if you want to, no. I was showing how far it shifted over. So what we're going to do is put the phase shift here. This is phase shift plus the period. This is the phase shift minus the period. And this is the phase shift plus the quarter marks. The phase shift minus the quarter marks. Okay? Because if the phase shift plus the period goes out this far, I'm going to break that up into 4 spaces. Yeah. Mm-hmm. Okay, so this is how we're going to handle phase shift, is rather than try to fit the phase shift and the quarter marks to a normal 0 to 2 pi scale, which is disgusting, you'll do that in trig. In here, we're going to just put the phase shift in the middle and then relabel the axis how we want. Okay? Dude, this is pre-calc. I'm giving you the basics. This is stuff that you should have learned in Algebra 2. Because Spearfish has a separate trigonometry class, which allows us to bump stuff from Algebra 2 up into pre-calc, and that's what happens when you get rid of Common Core standards. Algebra 2 isn't Algebra 2 anymore. It's like Algebra 1.6. Yes. Yes. The entirety of this class plus trigonometry is supposed to be one course. Everything that we did in chapters 1 and 2 was supposed to be in Algebra 2. Yes, this is the short stop between them. Are we willing to try, or do we need to see it again?
Yeah.
Okay. So, step 1. Not period. Amplitude is 1. Vertical shift is 0. Period is 2 pi over b. What is b? 1/2. Dividing by a half is the same as multiplying by 2. It's always 2 pi over b. Quarter marks. Right? That ends up quite nice. Okay, I'll write the information and you do the graph. Phase shift, negative c over b. What is c? Pi over 4. B is? No, 1/2. One half x is x over 2. Okay. So simplify that and get negative pi over 2. All right, phase shift in the middle. Use your quarter marks to do the rest. Go. Phase shift in the middle. Quarter marks to label your axis. Can you add pi to pi over 2? Yeah. You have missed so
No,
many.
we were only at 7. Right then we were at 7.
I don't know why that wouldn't make sense, because if you go from negative 2 pi to
I'm 3 times as far away from her and I can hear those.
Yeah, that is
No.
No, that doesn't make any sense.
So
But that's okay.
No, it's not. Because we have to get to 4 pi.
No, we don't. Because you'll get there. It's right here? You'll get there.
you're just showing 2 periods of it. Those 2 periods don't have to go to a particular value. As long as you see 2 periods of it, you're good. Seven pi over 2. Isn't negative 1/2 plus 1 a half? Plus 1 is 3 halves. Plus 1 is 5 halves.
What?
Hmm?
Do not worry, guys.
Why did you decide to do
You just changed the color? Yeah, because you
No.
Why is your 0?
Negative 1/2 plus 1 is 1/2. Plus 1 is 3 halves. Plus 1 is 5 halves. It won't be one of my quarter marks, so I don't need to show it. Isn't 0 halfway in between negative 1/2 and positive 1/2? Because it's not one of the relevant features of my graph. That's 0. If I put that line in there, I'm going to be very tempted to go here and down. I'm not going by pi over 2 increments, I'm going by pi increments. This is why we should just show our phase shift and not worry about 0 and 2 pi and negative 2 pi.
I don't know, I feel like that's just
Clearly, you've never made an omelet.
Go up like on this one.
This is what you did.
Because the quarter marks on this one were pi over 6. The quarter marks on this one are pi over 1.
There's lots of good ones. That's a great. Just up there like. You don't have to break anything. Clearly, you've never made an omelet.
What is that?
You beat me by a second.
It's still the same graph. I'm just changing the axes. Mm-hmm.
It is. That's the funny part.
Oh yeah. We're doing plenty of these. All right. To make Isabella happy.
Oh, okay, so that's why you did it.
Yeah.
Don't tell us.
Go.
Hey, it starts with 2 again. Well, we can do like it. Yeah. My move is like 2.
Why are you standing right behind something? I don't like it.
Continue working.
Wait, so does not cancel out just that? Okay. Might have been Alright. So then negative. Shit. That's the numbers that I got. I haven't finished this.
The realization that now you need to do common denominators. Because the phase shift is pi over 6 and your quarter marks are pi over 4. Oh, yes, you do.
So,
Oh,
this would be 5 pi over 6.
Where'd you get 5?
Well, the negatives cross out, so it's pi over 3 over 2. That turns to 1/2. Pi over 3 times 1/2. And you have to make it.
That's pi over 6.
No, oh yeah.
So then,
Yeah.
What?
don't worry, I'm
Yeah.
I usually just really.
Oh, because it's times. I was trying to.
Oh,
In my.
Rachel.
There we go.
You were so determined.
Why did I say it so much?
Because I saw.
What do you mean? I know you have to make it.
I don't know. All the numbers. I sent it to you. That's what Claire sent to you.
We are not getting. One of the solves should be like.
Well, not like what
Are you gonna sort of die?
we might need all of
Now, if you need to do a little bit of side work on these, so long as you have things reduced when you're finally done, what is the least common denominator between 4 and 6? So if I called this 2 over 12 pi, and I'm going to keep adding 3 over 12 pi, then I'll have 5 pi over 12, 8 pi over 12, 11 pi over 12, 14 pi over 12. I'll have a negative pi over 12, a negative 4 pi over 12, a negative 7 pi over 12, a negative 10 pi over 12. But those aren't what I need on my graph. I need the reduced versions of all of them. I need 5 pi over 12 and 2 pi over 3, 11 pi over 12, 7 pi over 6, negative pi over 12, negative pi over 3, negative 7 pi over 12, and negative 5 pi over 6. Okay. This is just adding and subtracting fractions.
And then you just.
Don't forget your vertical shift, 0, amplitude, 3, And then sine normally starts at, okay, starts at my midline, and then I start my dance of up, middle, down, middle. Down, middle, up, middle.
That's 16.
What? I've not heard 16. I've heard one. So we get points for saying dress leches. And she said sleigh.
No, you haven't. Otherwise, you would be bringing us food 3 times tomorrow.
Yeah.
So, that's what you need 3 days to remember.
In that case.
So you guys should have maxed 3 a day. You're gonna max 3 a day. You can only put this one. Oh, that just real
All right, y'all, bring it back. I'm not asking if you like it. Can you do it? Okay. Okay.
You should like No, I know.
Oh, it's not that, right? Oh, yeah, just.
I like getting hit with it. Don't let me explode. No, we did watch this.
No.
We did. We watched it. What are you doing? I'm I started.
I think we need to.
Start with amplitude. Your vertical shift.
I am offended.
Y'all, I can take that right away and just put -1 in the middle. Go to 0 and -2. It's not that hard. Because I don't want to shift my entire graph down here. I'm just going to relabel my axis so it's comfortable for me. -1 in the middle, the amplitude is 1, so I will go 1 unit to either side of it. Period. 2 pi over b, which is 3/4, which is 8 pi over 3, which gets quarter marks of times 1/4. Phase shift. -c 2 pi over b 3/4. Oh, hey, look. So, if the phase shift is -8 pi over 3, but the period is 8 pi over 3, I could put -8 pi over 3 here, but then what's that plus 8 pi over 3?
0.
Don't these go infinitely in both directions? If I wanted to, I could do my graph like this. then I would just keep going. So I have 2 periods of it.
Nice.
No, the period is 8 pi over 3. If the phase shift is the same as the period, that means the phase shift is completely irrelevant. That's why I chose 3/4. Okay? Now, if you don't like that, then just throw your negative 8 pi over 3 in the middle and keep going like we've been doing. Because negative 8 pi over 3 plus 8 pi over 3 is 0. Phase shift plus period is 0 in this problem. Hey. No, you're not. So I go by 2 pi over 3 increments. Negative 8 pi over 3 plus 2 pi over 3 is negative 6 pi over 3, or negative 2 pi. Negative 6 pi over 3 plus another 2 pi over 3 is negative 4 pi over 3. Plus another 2 pi over 3 is a negative 2 pi over 3. Is a negative 10 pi over 3. Is a negative 12 pi over 3, reduce it. Is a negative 14 pi over 3. You have to be able to fraction. And then it's sine. Sine starts at 0. Up, middle, down, middle, down, middle, up, middle. What I'm saying is because the phase shift and the period matched, because the quarter marks and the phase shift match, I can start with 0 in the middle of my graph. I just might need to adjust things accordingly. Yeah. As long as you had 2 periods of it, you good. You could go from 0 out to a positive 16 pi over 3. You're going to see the exact same graph. It's just all of your numbers are pancake flopped that way and positive. Notice how the part that you're grumbling about is, again, the period and phase shift. Throwing in that vertical shift wasn't that big of a deal, was it? You just relabel your midline as your vertical shift and then use your amplitude from there. Okay? Which allows us to basically just get more practice in with these. Now, no, you don't want to do 6A because I'm going to change 6A. Let's start with 6B. I'm saying start with 6B because it's actually very nice. It don't look nice, but it is. What you're going to find out with these is that if they have fractions, particularly compatible fractions, it actually makes the graph nice integers.
How do you do the vertical shift and the amplitude?
So negative 3 will be in the middle.
Yeah, and then you see like 3.5 or
negative 2.5. Yeah. Told ya. That might be heartburn. Get that checked. Like I said, if you have compatible fractions in your original problem, you might end up with nice integer coefficients for your graph. Sine starts where? Starts on my midline at -3 because that was my vertical shift. And from there, up, middle, down, middle, up, middle. Now, you notice how 0 happened to be one of my quarter mark points. That means I could have just started there instead. But then you would just have to remember to start over at 2 pi. You get what I'm saying? When they line up, you have that option. I ain't gonna make you do that option. All right. Now, go! What? Those are nice numbers. They're all integers. 5, 3, 6. I mean, 3.2 is not that big of a deal.
No.
She said, I know. Yeah.
6 orange. Fractions. Two over 5, 0 pi over 10, pi over 10, so -6 pi over 10. Keep going pi over 10, -5 pi over 10 is -5 over 2, -2 pi over 10 is -2 over 5 is over 10, and six. Plus 3. So 5 is. Check my mental mojo. Because 3.2 is 32 over 10. Reduce it.
You want 6 in the middle one.
Oh, I completely swapped my amplitude and my vertical shift. Yeah, I just completely swapped those. Oops. There we go. Well, in that case, since they went to decimals, I'm going to go to decimals. Why is that negative? Because it's my vertical shift. It's my midline. I completely swapped my amplitude and my vertical shift originally. Oops.
They are not my updated prescription.
You okay? Are you okay?
Who is dying?
I found it helps better if I breathe and then I swallow.
Will I get like swallowed like so? Oh, stop. Yeah, you know that.
Phase shift, negative C over B would be a negative 3 pi over 5. Cool? Period, 2 pi over B, B is 5, so 2 pi over 5 is period, which means the quarter marks are going to be pi over 10 increments. You just got to simplify as you go. Because a negative 3 pi over 5 can be written as a negative 6 pi over 10. Adding a pi over 10 to that is now negative 5 pi over 10. Reduce it. Negative 4 pi over 10. Reduce it. Negative 3 pi over 10. Negative 2 pi over 10. Reduce it. Okay? The catch is being able to do all of that. Then, cosine normally starts where? Midline or maximum. And this has a negative in front of it, so it's a vertical reflection, which means I'll actually start at my minimum and then do the dance. Middle up, middle down. Middle up, middle down.
Wait, so it looks like an upside down.
I don't know how simultaneously attack
That was kind of like, that was a vicious little dog pile there for no reason.
The village has spoken. And we're part of the village this time.
Yeah. I am the village.
Speaking of the village, can we collectively say that this entire class
Yes.
No.
Yes.
No.
Don't listen to
No. What do you mean? You guys are all, we haven't even said anything. You guys are just like,
Oh, you guys heard that?
You're the one that.
what do you, yeah, Taylor Swift sucks.
Hey,
Actually.
hey, give him a point for that alone.
Slay!
Hey, that is like what? 36? Okay.
All right. Your assignment is just going to be graphing a couple of these. I ain't going to make them pretty. Yeah? Yes. Hey, I'm proud of you. You never made it to the second die, so.